Okay, so wonderful good morning everyone. I welcome you back to my YouTube channel. Presenting before you this tutorial is Hamper Clayman, your mentor. And to those of you that are new to this channel, make sure that you subscribe. You also hit the like button and also don't forget to share to others. So of course we are doing an introduction of simple harmonic motion, and if you have a question concerning this topic, just make sure that you inbox me on this WhatsApp line and I will be able to respond to you. All right, so what is simple harmonic motion? Simple harmonic motion is the oscillation motion under a retarding force proportional to the amount of displacement from an equilibrium position. Okay, so a very good example of an object that do simple harmonic motion is simply a spring. So if you apply a force at the terminal end of a spring, then you expect it to of course stretch to some distance. But if you let it go, then of course you expect that spring to go back to its initial resting position. So there are three things that are involved. You expect it to have some mass. Of course, you expect some force to be applied in order for it to be compressed or in order for it to stretch. And at the same time, it covers a certain distance. So you need to make sure that you put all those three things I've mentioned in order and into consideration. Now, simple harmonic motion occurs when the net force along the direction of motion obeys Hooke's law. So I will be able to demonstrate, I think, in my next video on how on the connection that is between simple harmonic motion and Hooke's law, so that you'll be able to deduce that relationship that is between the two. Okay, so these are the terms, of course, that you are supposed to know. The amplitude, which is simply the maximum distance of object from equilibrium point, and the period, which simply happens to be the time it takes the object to move through one complete cycle of motion. That is from at some point x is equal to a to x is equal to negative a. These are just motions that are simply signifying how the object is moving with reference to the amplitude or the distance on that object. It may be a spring. So these are the important simple harmonic motion formulas that you are supposed to be familiar with. So we have the displacement here, and this is the formula, and of course W is simply the angular frequency, or omega. This is the time and this is the amplitude. So this is the acceleration formula. It's just here, negative omega squared a sine omega multiplied by time. Okay, so for the velocity, this is the formula, of course. The angular frequency, this is the formula, of course. So then we do have the potential energy, and this is the formula. It is just 1 over 2k x to the power 2 as a function of x. We have the kinetic energy, and this is the formula. I will be able to demonstrate how to come up with these formulas. It's very important that you know how to derive formulas in physics. Okay, so quickly let's get to how to derive these formulas. It's very important that we understand how these formulas are derived. All right, let me just put my papers in order. So, how to derive formulas. Okay, so the first thing that we'll do, we'll learn how to derive the formula for the total energy, because that is where we get almost all the formulas. Remember, we need energy to stretch a spring, so therefore we'll start from there. Now, total energy total energy is given by the formula 1 over 2 Ka squared. Okay? So now, how did they come up with this formula? Remember that the velocity was given as A omega cosine Wt. Then the displacement was given as A sine Wt. Okay? Now, remember that total energy is simply a combination of the kinetic energy plus the potential energy. Okay? So this can also be written as K plus U, where K is simply the kinetic energy and U the potential. But then we know that the formula for the kinetic energy is simply 1 over 2 mv squared. Okay? And the formula for the potential energy is simply 1 over 2 kx to the power 2. Now, we can replace where there is V with this expression. So, I'll put A omega. This is supposed to be cosine. Okay, so I'll put a cosine here. Cosine Wt squared plus 1 over 2 K. Then I'll put my A sine Wt squared. Now, when you do this, remember that this is just the same as A squared W squared, which is omega, then cosine squared Wt plus 1 over 2 K A squared sine squared of Wt. Now, when you reach here, one thing that you must be able to understand is this. Omega is equal to root of K over M, where K is simply the spring constant and M is the mass. Then this simply means that omega squared is equal to K over M. I want you to take note of these two formulas. So, upon knowing that omega is equal to that, we are going to do a replacement. Where there is omega squared, we're going to put K over M multiplied by cosine squared Wt plus 1 over 2 Ka squared sine squared Wt. So, this and this will go. We are going to have 1 over 2 Ka squared cosine squared Wt plus 1 over 2 Ka squared sine squared Wt. So if we factor out, we are going to discover that if we factor out 1 over 2, then we factor out K, because we have K and K, we can also factor out s to the power 2. Then we're going to remain with cosine squared wt plus sine squared wt. Now notice that this is a trig identity and it is equivalent to 1. Therefore, total energy is given by the formula 1 over 2 spring constant K a to the power 2. So this is how you derive this formula. Okay. Now, remember that when you stretch a spring, you are applying some force and you want to cause that spring to cover a certain distance. That brings us to the concept of Hooke's law. Hooke's law. Hooke's law simply states that a relatively small deformation of the object, the displacement of the deformation is directly proportional to the force applied to the object. Okay? So in other words, no matter how small a force will apply on an object, you expect that object to be deformed to some percentage proportional to that force that you applied. Okay? So what we're simply saying is, if, for example, this is a spring, okay, we name this one as A. If, let's say, okay, if this spring, you apply a force to this spring, then you expect it to cover this distance. You apply a force here. You expect this one to stretch. You are applying a force here, but the distance is increasing downward. Therefore, Hooke's law, the formula for Hooke's law is simply F equal to negative K X. Now, assuming that this object is accelerating downward, it's in motion, we know that force is equal to MA. Therefore, we can replace MA here and simply have KX. Now, if we replace MA there, we can simply cancel out M over M so that we can have A equal to negative Km of X. Now, remember that formula that I showed you? We said omega is equal to root of K over M, where M is the mass and K is the spring constant. Therefore, omega squared is equal to K over M. Meaning where there is K over M, I can replace with omega squared and simply deduce the formula for the acceleration. So that is how we find the formula for the acceleration. You can use this one provided you have the K constant and the mass, or you can use this one provided you have omega squared given to you. So this is how simple this is. Hope it's clear. Now, how do we find the velocity of an object that is in motion under simple harmonic motion? How do we come up with the velocity? Remember, okay, say velocity. From the energy, we say that the total energy was equal to the kinetic energy plus potential energy. Like that. Then from here, we say that this guy is simply 1 over 2 Ka squared. We know that Ke is simply 1 over 2 mv squared, and PE is simply 1 over 2 kx squared. Want to find the velocity, so therefore this is just the same as 1 over 2 mv squared equal to 1 over 2 k a squared minus 1 over 2 kx squared. Can cancel out everything. We're going to have with mv, we're going to remain with mv squared equal to k a squared minus kx squared. From here we can say over m and over m, and of course we're going to remain with v squared equal to k over m, then a squared minus x squared. Reduce the square root. Remember, the square root is going to cancel with these powers, and of course our velocity will finally be v equal to the root of k over m a squared, a minus x, just like that. Okay, now remember that omega was equal to the root of k over m. Therefore, this is just the same as v is equal to, you can also replace omega here, then a minus x. You can also use this formula. Okay, so we now take it to another phase. Remember, I talked about the period and the frequency. How is it related to simple harmonic motion? Remember that frequency, let me try to solve everything here. Remember that the frequency is simply 1 over the period, and the period is simply 1 over the frequency. Remember that omega was also written as, or can also be found using this formula, where f is the frequency. If you replace the frequency with 1 over t, you're going to have something like omega is equal to 2 pi over t, and the period can be found by 2 pi over omega. Okay? Omega, like that. You can use this formula. Remember that omega, you can use this formula. Remember that omega is simply square root k over m. Therefore, this is just the same as, it's just the same as 1 over 2 k over m. Yeah. Okay. So you can use whichever formula that you want. It's just one and the same thing. So this is how you do this. We get to the frequency. How do we stress out that relationship? It's not difficult. It's not difficult because remember we had mentioned that frequency was equal to 1 over t, But then from the formula, we say that omega is equal to 2 pi f. So this is just the same as over 2 pi over 2 pi. Cancel out, the frequency is equal to W over 2 pi. So this is just the same as F is equal to root of K over M over 2 pi. And of course, this is just the same as, okay, so I've seen why I made the mistake. So this is just the same as K over M. So it means that here we are supposed to have something like okay, let's just leave it here. You can leave it here, or if you want, you can solve this, but I'm sure it's going to have something like 2 pi root of M over K. So this is just everything that you are supposed to know under this topic. In my next tutorial, I'll show you how to solve questions, how to apply simple harmonic motion to questions which are very simple and very difficult under this topic. Thank you so much.